All right. Today's our second lecture of the course. Today we'll be talking more about file processing. Today's lecture will be more hands-on. If you're in the Discord channel already, you might have seen this announcement, but we have a Git repo that you can clone right now. Just a show of hands, who does have a laptop and like a terminal with them that they can use during today's lecture?
Terminal.
Yeah, so if you have a Mac, then you can use your terminal there. If you have Windows, then it comes with the terminal that might be fine, but also WSL will be even better. And then if you're using Linux, then you're already set. Does anyone not have any of those three with them? Okay, perfect. If you don't have Git installed, I would suggest installing that. You can clone this repo here, but if you don't have Git installed, then you can also just browse to this link, and I'll give you guys a moment to at least type it in first. But again, if you are in the Discord server, then you can just paste it directly.
I'm like rapidly adding people to the channel right now, so check again if you haven't seen it.
If you don't have Git, then you can just click code here and download zip, and then extract the zip, and then you'll have the folder that we'll be using for today's lecture. Anyone need more time to do that, or are we all set?
Permission. Can I read from the repository?
It's public. Is anyone else getting that error, or you were able to clone it? Not able to clone it? Do you want to make sure that you typed it in correctly, just to double check? Did I type it wrong? No, I don't think so.
Let me check that.
You're good? Okay.
Well,
Try again and let me know.
See if any non-officers, because it might be like.
Oh.
No, it is public.
You're able to do it? Same error? That's very weird.
You can, download the zip or.
Well, no. Are you even able to browse to it? I can browse to it.
Incognito tab?
Yeah, in incognito.
It is.
That's very weird. Wait, and this is just using git clone that isn't working? Wait, who is it not working for? That's like everyone. Okay.
Let me just look at the permissions.
Sure.
I'll handle the permissions and let you know what's going on, but.
If you go to this website, are you able to see it there? Like,
You should still be able to go navigate to the website and just like look at it from there.
could you send the link in the Discord server and see?
Sure.
Oh, wait, it works. Okay.
It does work?
I just did it.
Yeah, because he didn't have it in earlier.
Yeah, just make sure.
Oh! Wait, that might explain it.
It's,
Uh,
but yeah, I just did it, but
Okay.
let's see. That's fine.
Is anyone else able to get it working? Yeah, a few. Who tried it again and wasn't able to get it working? Okay, that's very weird.
I'll continue troubleshooting.
Sure,
and
yeah.
just move ahead.
Okay, we'll move on when it becomes relevant. Again, I'll check again. But Jason sent the link to the repo, so you can at least download the zip. In the future, we'll try to troubleshoot it and see if we can get it working, so that you can just like git pull whenever we have new content, rather than having to re-download the zip. But okay, let's move on. All right, course content now. So this is a bit of review from 36A, but as we know, programs can read and write in multiple different ways. So if we're just thinking about it from the perspective of a terminal, programs read from standard input, or std_in, and then they write to standard output, or std_out. This is sort of review from C. Whenever we had to, most of our programs, we'd start with hash include stdin.h, right? Or stdio.h, sorry. And whenever we want to print, we would use printf, which is included in that library. If you want to read characters, you would use readline or scanf, things like that, which are included in that library. All of these commands are just interacting with the standard streams, standard input or standard output. Think about the command echo that we talked about in Tuesday's lecture. What does that do? Just in those terms. Shout it out or raise your hand.
It just outputs like what you wrote down.
Right, so it's writing to standard output. So as part of the sample code, try unzipping it if you're able to get it downloaded, and then open it in your terminal. So let me actually just do that right now as well. I will clone this into my temp. So new terminal hash cd temp, and then I will git clone this, and maybe I'll see the same error. I'm not actually sure. No, I was able to get it working. Okay, I got lucky. So cd into that directory. I have it open already in another place, and then if you are at the root of the Git repo and you type ls, remember ls just lists files where you are, then you'll see lecture 2, and then you want to change directory into lecture 2 as well. Okay. Everyone good? Does anyone not have it open yet and it just wants me to wait for a bit to get it open? Yeah? Are we able to get it downloaded, or you're gonna do the zip? Okay.
Yeah. You need an SSH key setup. Oh yeah, if you don't have GitHub set up, using
okay.
git pull might be an issue, but
I guess
downloading zip still works.
I think you might be able to git clone using HTTPS if you just use the the full repo name, and then that would work, unless I'm mistaken. But yeah, the command I included here is specifically using SSH, which might not work for everyone. Now that I think about it, go ahead.
Maybe off topic question, but like in the future, like is it better to do like HTTPS or SSH for like
So from what my understanding, which is incomplete, but my understanding is that SSH is the better way to go, because with HTTPS, it expects that whenever you authenticate, you're using your username and password, which I think is now deprecated, so they won't allow you to do that anymore. If you're using SSH and you have like a private repo, then that will allow, because SSH is using your pub key and your private key in order to authenticate you. When you're doing it over HTTPS, you're basically typing in your password in your terminal every time, and GitHub doesn't want you to do that anymore, so they just don't allow it.
Okay.
But in this case, this isn't a repo that you all are writing to. It's just for me, Jason, Ethan, so it doesn't matter which one you do, because you'll never have to type in that password. Good question, yeah. All right, are y'all good? Okay, cool. Let's move on then. Let's take a look at sample program 1 and look at the code. I will, so let's do list again, list files to see what's up. We can see that there's a bunch of different folders that hopefully we'll get to look at all of them today. Sample program 1 is O1 stdio. So let's change directory into O1. I'm going to hit tab now, and it'll autocomplete, and then I'm going to hit enter. Let's list files again and see what's here. Okay, we have a main.c file. Let's first just look at, well, actually, this isn't usually how you would do things, depending on how you feel, but I just feel like let's just run this program, because I'm pretty sure it's not malicious, because I wrote it myself and I think it's not malicious. So I'm going to hit gcc and main.c, and that'll compile the program, right? So review from 36A. Let's list files again and see what we have. We have our a.out file, our a.out file, which we can just run directly. And let's see what it does. Okay, it says type some words and then type enter. So I'm just going to say, hello, this is Akil, and I'll hit enter. And then it's printed that out to the program. So the purpose of this exercise was just to understand what this program is doing. So again, we're talking about in terms of this 2 standard streams, standard input, standard output. What is this program doing? Feel free to shout it out again. Go ahead.
Copying your input and outputting.
Sorry, a bit louder.
Copying your input and outputting.
Right, so it's reading from standard input to get your input and then just outputting it right after. And then we can take a look at the code. It's nothing too complicated, but let's just do view main.c. Or you can just cat it. Let me just cat it, actually, because we did talk about the cat command last time. So we can see here that all there is, of course, it's printing that message at the top. So it's putting that into standard output. And then it's polling. So we can see this while loop here. It says get C from standard input. So get a character from standard input. While that character is not the end of file character or a new line, so new line would indicate enter, put the character onto standard output, and then get another character from standard input again. So just keep going until it sees a new line. So you can see here explicitly that it's reading from standard input, and then it's putting 2 standard output. So you can see how it's interacting with these 2 standard streams of the shell. So the point I wanted to make here is that programs are always, basically every program that we use regularly in the terminal is doing some type of input and some type of output. That input is often from standard input. That output is often to standard output. And during today's lecture, we'll look into a few commands that do that and how you can interact with them. Okay, let's move on. Any questions about that? All right. Yeah, I think it's pretty relatively basic stuff that we just remember from 36A. I'm just going a bit deeper into how it works from like the perspective of the terminal. Okay, so last lecture we talked about WC. Recall what that does, the WC command. And if you forget, then you can always look at the man pages, so just type man WC. So what does this command do?
Anyone want to shout it out? Who's the fastest typer among you?
Word count, right. So let's look at the man page, just in, because oftentimes we forget what we're in the middle of, seeing all of these commands. It prints the new line, word, and byte counts. So new line count would mean the number of new lines, the number of lines, the number of words, and the number of bytes, or the number of characters. So yeah, that's what the WC command does. Let's just run WC and see what it does by itself. So when I say run WC, I mean don't pass any files into it. Just run it by itself. So I'm just going to hit run. And we can see it's there. It's just waiting for something. And so let's look at the man pages again. I'm going to hit Control-C just to exit the commands. And let's look at the man page again. So it says prints new line, word, and byte counts for each file, and a total line if more than one file is specified. So we didn't specify any files, but we were still able to run this command. You can see, remember, this was a small point we made last lecture, but if something is in brackets, these square brackets, that means it's an optional argument. So you can see here for WC, the files are in brackets. So you don't actually have to pass in any files into there. And so the reason for this is that WC, along with many other commands, they take files as an optional argument. The other way you can interact with them is by passing something into WC's standard input. And this brings us to, and so the question is how do we actually pass something into the standard input for another command? And that brings us to pipes. You might have seen these last lecture. We didn't get time to actually talk about what exactly they're doing, but you can see this format here. So command A, pipe, command B. So when you have something in this format, what you're saying is first run command A. Command A will output some things into standard output and take that output and pass it into the input of command B. So when we had a command like WC, when it was just stalling there, it's because it was expecting something into its standard input. Right now, it's giving us a prompt, and we can type whatever we want. And once we type the end of file character or type Control-D, then it will stop. So we can just try that right now. So right now, what my point is that WC is waiting for us to give some useful input to it so that it can analyze that. So I'm just going to type a few words like, again, just hello, this is Akil. And I'll hit the end of file character. The end of file character on my computer is Control-D. I believe it is on most systems. I think if you're on a Mac as well, it is Control-D, not Command-D. So I will hit Control-D. And you can see here its output, 0 lines because I didn't even hit enter, 4 words, and 19 characters. I'll try it again, and I will hit enter this time. So hello, this is Akil. Hit enter, and then hit Control-D. And you can see now it says, okay, there's 1 line, there are 4 words in this line, and there are 20 characters, 20 bytes in this line. So right now we were interacting with WC directly. We were passing in a string of our own choosing into WC to see what it wanted to say. And this is a bit more of a manual process because we didn't have a file on hand. We just wanted to type something into WC's standard input and see what it tells us. But what if we wanted to take some other command and find out what it has to say? So for example, when we want to run another command, see how many lines are in that command. So I believe there's another exercise for this specifically. Let me say ls. So I did change directory to move back into the lecture 2 directory. I did ls to see what's in here. And then we can change directory into the second exercise. Let me drink some water real quick.
Any questions so far?
Am I going a bit too slow, or are we at a good pace? How do we feel? Good pace, too slow? Okay, cool. Then I'll continue at that. So now we're in the second exercise. Let's hit ls just to see what's in here. We see instructions and lorem.md. An MD file is markdown. Excuse me. Let's view the instructions. So I'll do cat instructions just to see what's inside of it. Okay. Find 3 different one-liners which use WC to output the line, word, and character count of lorem.md. And we can read what is in this lorem file. You can kind of guess it just based on the name. It's just random text that I generated using some website called Lorem Markdownum. And so like the prompt says, we want to find 3 different one-liners which use WC to give us the line, word, and character count. Before we do that, let me just talk about what's going on here. So if you wanted to pass something into WC standard input, remember in that first exercise, we just ran WC, we typed stuff, and then we wanted to see what is in its, and it is reading standard input and giving us the word counts, right? And so with piping and with read, and we can change the way that we're passing into standard input. So if we replace this command B with WC, then we can run some command A. It will produce an output that is then passed into the input for WC. So instead of having to type any words that we want, like for example, I typed hello, this is a kill, and then typed enter and control D to end the stream, we can take any other command output and pipe it into WC, and WC will read that output as its own input. Does that make sense? Okay.
Take that as a yes.
So here we can think of multiple ways then. We can think of another way to read from to read the output into WC. So we have this file, lorem.md. We ran cat to put it into standard output. If we want to have WC read this into its input, we can use the pipe character and then type WC. And what this will do is it will run cat.lorem.md, so it'll make this output. But instead of putting it into the terminal's output, it will pass it into WC. It'll pass it into WC's input. And then WC will read this and produce those same 3 values that it gave us before, the line count, the word count, the byte count. So let me hit enter. And we can see here it gives us 14 lines, 103 words, 687 characters. Yeah, that looks like about 14 lines. We can say that that's probably pretty accurate, and it's doing exactly what we want. There's another way that we can use WC. I think we talked about this last lecture. Let me just type man WC again. I know I keep going back to that, but really the man pages are just the best way to learn about what a command does. So it prints the new line, word, and byte counts for each file. So we mentioned this earlier. You can always just pass in a file directly if you choose to do so. So if we wanted to find how many words, lines, and bytes are in lorem.md, we can just type WC and then type in the name of the file that we're looking at. So let's do WC lorem.md. And that'll also work. So it gives us, again, the word, line, byte counts. Sorry, not in that order, line, word, bytes. Does that make sense? Okay. And then there's one other way that we can do this, the same exercise of just trying to pass something into WC's input, and that's through something called a redirection. So here, instead of having taken in another command, we can directly pass the file into WC. So a redirection like this, where we have some command, and then this symbol here, and then file, allows us to pass in this file as the input to this command. So for example, if we had some file and we wanted to pass it into WC standard input, then we would use this redirection pointing left, pointing into the command, in order to pass this file into the input of WC. And so we can try that again. So let me just run WC, and I will pass in lorem.md to redirect it. And again, so we can see that this gives us the same numbers that we got from the previous 2 methods. And so we've kind of completed the prompt of finding 3 different one-liners that use WC. Does that make sense? Were you guys all able to run that on your own computers? Okay. Any questions about it?
It's like practical use. I know 36A was a requirement, but if you're testing programs that require some kind of input, you can put the input in a file, pass it into your program, and then just have that as your test, essentially.
Yeah, I'm not sure how who y'all took 36B with, but at least I remember that I think this was something that was pretty common. So they would give us test cases, and if we wanted to, or like 122A classes like that, they would give us some test cases, and you can always pass them in using this. So all that method was doing was taking in the test case file and then passing it into the standard input of the program that you had to write. Okay. Let's move on. There's a few other types of redirections that we can talk about. So one of them is if you type in two of the left-facing redirections, then it'll pass text in as standard input. So what does that mean? How is that different than what we were doing before? So what we were doing before is that we would type in a file name and it would pass that file. But if we wanted to just pass text in, we could use this character. We would use two of those instead. So for example, if I wanted to pass in text into WC, then I could type in WC, double less than, and then type any end of stream character. So the reason why this EOF was here is that it represents the delimiter that we want to use. So because we're typing in text and the terminal doesn't know when our text ends, it doesn't necessarily know that a new line means the string is done, because you can have a string that has new lines in it, right? So you type in some delimiter of your choice. The standard is to use EOF, which means end of file, to represent the end of the string. So I think it might make more sense as an example. So I'll type WC, double less than, and then EOF. I'll hit enter, and then I can just type whatever string I want. So like hello, I am currently in my terminal. And I'll type EOF again. EOF is the delimiter, so if I type EOF now, it'll indicate to the program or to the shell that this string is now done. And you can see, okay, it says 3 lines, 7 words, 36 characters. This is small enough where I can count it. It says, so it's 1 line, 2 line, 3 line, 1, 2, 3, 4, 5, 6, 7 words, and 36 characters we can assume is correct. So yeah, this was a way for us to, instead of passing in a file, we were able to pass in a string into WC. And this might seem kind of pointless to do it like this, because of course you can also just type WC, hit enter, and then just type hello, I am currently in my terminal, and then hit Control D, and it'll give us the same output. Like, it does the exact same thing, except now we're in this format that we can easily paste into a script. If you pasted this into a script, it wouldn't work, because remember, you had to type Control D at the end of this line to indicate that the stream was done printing. So if you wanted to have a script, like a file that stored this command, you would have to use a more explicit method like this to tell the terminal, or to tell the shell when the string is done. If you use a method like this, it would basically continue reading for input for eternity until you type in Control D. So it wouldn't work in an automated way.
You want to give the practice? Do you want to try it out?
Yeah, let's try it out. So, so I had this command here. Let me just make like a new script here. So this doesn't exist on the system, but I will. I'm gonna just use. I'm just gonna use Vim to like type this out. If you would like to follow along, feel free to. In whatever text editor you choose to do, it doesn't have to be in the terminal. So I'm gonna just make a script called main.sh. Let me add in to shipping. All of this stuff we'll talk about more later. And I wanted to type in that string, right? So let me just type WC EOF hello, I am currently in a script, and then EOF. And if I wanted to run this script, I would type sh main.sh. So sh is shell, so it indicates to execute the main.sh script. I hit run, and it gives us, it's a bit of a different number of characters, because I guess I should have kept it consistent. Let me actually do that, sorry. I'm currently in my terminal. I'll change the text that I have there so that it matches up with what we had before. I'll run main.sh again, and it lines up with what we had before, right? So this is a format that works well in a script. I'm using in this double less than, and it worked fine to indicate that this is the end of the string. But what if I use that other method, right? The other method being just typing in, hello, I'm currently in my terminal. Let's just try typing that and see what it does. I'm gonna save this file.
So good at Vim, guys. I bow down.
And then, okay, and then you see that I'm running this program, and it's stuck there. It's still just waiting, right? If I put this into a script, it doesn't know when the end of line character is, because you can't type end of file as a character. End of file is the end of the file. And so the only way to indicate that is through the terminal. So the terminal is your interface to this program, right? The terminal you need to tell the terminal when to tell the program that this is the end of the file. So I'll hit Control D now, and it just gives us an error basically. It doesn't even, it reads these 3 lines as commands that don't exist. Hello isn't a command, I is not a command, in is not a command. And so basically what we just saw there was it ran WC. It hung for a while because it was just waiting for input, but nothing got passed in. And so using the method of just typing in directly, like whatever you want, and then hitting enter and control D, it works well if you are interacting with the shell. But if you're writing scripts to do things automatically for you, it won't work. You have to use a more explicit format, like using the double less than to redirect in.
What does control D stand for here?
I'm not sure what it stands for, but what it means is it'll take whatever characters are the terminal has stored in its buffer, and it'll push it to the program. So it's basically just
It's like a special character, that signal that just indicates what? End of file?
end of file, yeah. It's used as a substitute for end of file.
But this time you didn't give it any specific of like end of file character. Does it just automatically does that?
Are you talking about like in this example, like it doesn't do anything? Yeah, so what I was doing here is that, let me just type some text. Hello, I am in ECS198F. I'll hit enter. And so hitting enter doesn't necessarily indicate the end of a string, because you can have strings that have multiple lines. So the only explicit way to do this is through a character that isn't an actual character. So we would use a command like control D, because you would.
What's the difference between shift enter and enter, let's say, in terms of writing commands?
I think it depends on the command. So for example, let me, this is a separate question, so let me go back first and then I'll come back.
Okay.
But that's a good question. I'm going to hit Control D now, and then again, it just gives us that error. Control D indicated to the terminal that it should pass this string into WC. And you can see that WC did give the output that we would expect for this string. Like it's one line, it's 5 words, 22 characters, I suppose. It gave us the output for that string. But if we wanted to have a preset string that we're passing into WC, this format wouldn't work, because it's the program is reading this as commands rather than strings.
Yeah, so scripting is not the direct equivalent to typing in the commands directly and pressing enter after each one. I mean, most of the times, yes, but when you're handling text and input, it's not. So
Did
be
it
careful.
do the same thing when we typed in the command where we said WC and then
Yes.
EOF and then we put EOF at the end?
So good question. So the reason why that worked is because when you type in the double less than and an EOF, now bash is interpreting all of this as a string, and a string that doesn't end until you type in the delimiter that you specified. So I type in EOF now, and then you can see that this is all highlighted in red. This is just Vim interpreting what I'm typing. But now if I want to type in more commands like cat file.txt, now it's back to interpreting it as commands. So until I type in that delimiter, it is interpreting anything in the middle as a string. But the way that we had it before, it's interpreting all of these as commands. So if I typed directly, if I just typed cat file.txt, it starts interpreting as commands again.
I see, okay.
And so even it can go as early as right here. So if I typed cat file.txt over here, it would be interpreting this as a command. So WC is doing the same thing it did earlier when I just typed WC and it's just waiting for input. And so the only way we can pass in a string is by using that double less than sign. Make sense?
Yeah.
There was another question you asked after.
That was the difference between enter and shift enter.
Yeah, so that just depends on the program. So I think my terminal, for example, it'll use it to just put in a line break. So like if I don't really have a good example that'll work, but if I just type, I guess it depends on the shell. Usually I use fish rather than bash, but if I type shift enter there, then it'll just go to the next line. So it won't execute yet, if that
Yeah,
makes
because
sense.
like sometimes when we used to do like some type of execution for the class, they used to have us like put the code in shift
Yeah.
enter until we're done, then just press enter.
Yeah, so
I
it's-
was, like curious if there's any different.
My guess, and this might be wrong, but it would be good to check. And if you have the example, you can send it in the Discord and I can look at it after. But it's just that it's making a multi-line command. So
I think so.
yeah. Yeah. All right. Go ahead.
Double redirect still work for fish?
It does not work for fish. That's why I'm using bash right now, actually. It was for this one specific example. It will not work in fish. There are other ways to do it in fish, and I can show you that later if you'd like, after
Yeah.
class.
That's not crazy.
So what's being brought up is that bash is just one of the terminals and it has its own like scripting language. Because people are Linux users and they like doing their own thing. There's also other ones like Z Shell, which is on Mac, and Fish. They all have their own syntax, so what we're showing may not necessarily work on other shells, but I guess for the purpose of the class, most of what we're going to be doing is in bash, which is comes default with Ubuntu
With basically every distribution of Linux really uses Bash. There are some old ones or some smaller ones that'll use even lighter weight things, but Bash is pretty standard across Linux. You'll see it basically everywhere, so that's why we teach it.
Last question, I'm sorry for the...
No,
That's okay.
What's the difference between using the ch mod plus x something for permission or doing sh correctly? Because yours did not complain about not having permission
Yeah.
to use sh.
So this is a question about how we can run files. So what I did earlier was I did sh main.sh, and then that I forgot what this. Oh yeah, this was that wc command, right? So sh main.sh isn't executing the file as a file, or it is passing that file into sh, and then sh is running it. If you wanted to just execute main.sh as a program, then you would try to type /main.sh,
Yes,
right?
That's like...
And I'll hit it, and it says permission denied. And so if you once you add execution as a permission, and this is a command that we'll talk about down the road, or you can ask in Discord about it. Once you add execution as a permission, then it'll work. So then you can do this. So that's the only difference. It's just it doesn't have the permission yet, which is why we used sh.
Thank you so much. I just didn't understand the difference. I
Yeah.
used to use the second one. I just don't know what the first one was
Yeah.
without it.
Yeah, good question. I know we went on a bit of a tangent, but are there any questions about all of that? No? Okay.
Temperature check.
We're going to be doing these a lot because we're new to lecturing, so we want to just make sure. But, yeah. Okay, cool. We can move on then. So there's a few other redirects that we'll talk about right now. So if you want to write, so as we saw, WC wrote an output, wrote some stuff to the output, right? So let me WC lorem.md, for example. It writes the output, right? So it's taking all of this stuff and then giving it out into standard output, right? In the same way that if you had echo hello world, it writes that to the output. And so let's say we wanted to take this output and store it into a file. So we wanted to take the standard output of some program and then put it into some file. How would we do that? So the idea here is that we would use this other redirect, the greater than sign. So you're pointing right now into the file. So let me say I had a file called, I just want to call it file. So I want to take the output of wc lorem.md and then store it into file. So we'll write a command like this, which will take the output and put it into file. I'll hit enter. How can I view the outputs of file? Just a quick check. You could use nano. That's one way. Cat was another way to do it. Yeah. So we could use cat file, and that'll just give us the output, and you can see it aligns up perfectly. So we were able to store what we wanted to put into file. Excuse me. So that writes directly into file. So if I wanted to take another value and put it into file, then like for example, if I wanted to put the instructions into file, then I could do cat instructions and then redirect it into the file. And then if I cat the file, then it's the instructions. The instructions are not here. But let's say I didn't want to replace the contents of the file, because as you can see, when I catted file this time, now this line is gone, right? It was completely overwritten. Let's say instead of overwriting, we want to append. So we want to take this lorem.md output, sorry, the wc lorem.md output, and then append it as a new line in this file. The way that we would do that is using the double. So you just double it. So let me do wc lorem.md. I just want to add this to the end of the file.
MD.
Thank you. And then let's cap the file. And you can see now that it has been appended. And you can do this until you run out of disk storage, basically. Like I can just do it again. Let me cat. I'm using the up arrow to recall a command. So I'm going to hit up arrow twice. I'm going to hit enter. I'm going to hit up arrow twice again. And you can see it just keeps appending to the end of the file. And you can do that forever, basically.
Yeah. Terminal shortcuts are your friends. Tab auto-completion and up down are
our saviors, because we don't want to type that much. All right, any questions about the redirects? Okay, let me check if there are any examples about that I also had. No, that was it, okay. All right, let's move on to new commands. So what we saw before was just using pipes and redirects in order to interact with standard input and standard output. There's other things that we can do by introducing new commands. So what we did earlier was, remember we were taking WC and piping into it. we can also use other commands and pipe into them. So instead of piping into WC, there's a bunch of other commands that read from standard input, do something with that by being piped into that. For example, the T command. So we just talked about this, right? The redirect into a file. It has a big shortcoming, and let me just I'm going to cd into the T folder, so the third exercise. I'm going to type ls, and let's look at the instructions here. So cat instructions. Find a way to run main.sh such that it stores its output into a file and displays it in standard out. The way I wrote it like this for a reason, to try to emphasize the shortcoming with main.sh. So main.sh is an executable file. There was a good question that was asked here about whether we can run it as a program or just have to run it as a script. And I believe that you should, I don't know if, I'm pretty sure Git does maintain file permissions, so you should just be able to do /main.sh. Does that work for you all? Well, it'll work for me because I have I have my file permissions, but I'm just wondering if it'll.
It works.
It works? Okay, cool. So I'm going to run /main.sh, and you can see it's starting to fill up our screen with highs, right? So let's say we wanted to store the output of this command into some folder. So, excuse me, into some file. So
Redirect it to the
right.
file.
So let's store its output into a file. So let me just redirect it into a file.
You wanna overwrite it, or you wanna just append it?
Well, it was the file didn't exist yet because when we ran ls, it wasn't there yet. So it wouldn't actually matter either way.
Okay.
Yeah, because you would be appending it to an empty file, which just replaces, right?
Doesn't it create the file though?
It'll create the file, and then so my point was that since this is the first time that we're running this command, it won't do anything different whether you do a single or a double.
Oh, okay.
Yeah. Good question though. So you can see now that it's outputting into this file, right? The only way I can stop it is if I hit Control-C, and then I can. I think I left that running for a little while, so let me, instead of using cat to view file, I'm going to use less to view the file, which will allow me to scroll. And you can see, yeah, it's a pretty long file now. So the main shortcoming with using this redirect into is that we don't get to see what is currently being output. So it stores the output into the file, but while it's doing that, we're not able to see what's going on. Like, we're not able to see all of these messages. If you run main.sh by itself, you can see what the program is doing. But once you have it being redirected, you lose visibility until you end the program. So T is a command that kind of solves this problem. What it'll do is it'll write the standard input that is passed into it to standard out as well as a file. When we use the redirect into, it just stored it into a file, and we lost the visibility because it was no longer putting its output into standard out, right? So if we wanted to have it do both, we wanted to have our cake and eat it too, we wanted to store it into standard out as well as the file, we would use T. So let me just show how we can do that. So again, the instructions were find a way to run main.sh such that it stores its output into a file and displays it in standard out. So instead of having the redirect into, I'm going to put a pipe sign and T file. What this means is that main.sh will write to standard output. It'll pass its output as the input to T, and then T will output that input into our terminal as well as the file. So this will, again, probably make more sense once I hit run. And actually, let me just for proof that the previous command output isn't causing anything, I'm first just going to delete the file. So I put a hash here, which just makes this a comment, so it doesn't even run the program. It's kind of like writing in the double slash in C code, for example, or a hash in Python. I'm just going to delete the file, just so we're starting from a blank slate for sure. And then let me recall that command by hitting up 3 times. And then let me delete the hash. So now we can actually run it as a command. I'm going to hit enter now. And we can see now we're seeing the output of main.sh in our terminal. And based on how T works, and we can check this in a second, we will assume that the output is also going into the file. So I will now hit Control-C to end the execution of the program. And then I'll type cat file. And we can see now that the same output has been put in here, right? So we were able to see what's going on we were able to see what main.sh is doing in our terminal while it was still executing, and it was storing its output into file. Go ahead.
What does T stand for?
I got it. Please go ahead. Okay, hold up.
You know it?
Is it the vibes thing?
Yeah. I mean, it is like the phrase is like it teed off, like you split a pipe into two junctions. But yeah, T.
This is knowledge. This is neat knowledge.
Elite ball knowledge. Any questions about how T operates? Is there one case where kind of how T operates is kind of uncertain? Thinking of the cases we've seen with the two redirects. How do we handle what is T like is not obvious that it handles? I don't know if I'm phrasing this in the right way.
You're not. Because I'm not understanding the
You
question.
can handle a live session.
So I guess the one question I want to ask is, okay, T looks like it's just writing into a file. What if you wanted to append to a file instead of overwriting it all with T?
Use a dash A.
Let's look at the man.
Let's look at the man page. So I'm gonna have to type man t. Let's.
Not the animal.
Yeah, I was thinking that too. So we can see here that was a good point. So you use dash a or dash dash append, and it'll instead append to the file. So it doesn't overwrite it; it'll append to it, and it'll be a bit hard to see with this example because I didn't have numbers, but we can see that there's already oh, actually here's an idea. Let's count. Let's use WC in order to see how many lines are there right now. So I'm gonna use WC file, and we can see that there's 14 lines. It does line, word, byte, and since words and lines are the same thing in this program that only has one word per line, it's 14 words. And let me just run it again using t-a. So /main.sh, pipe it into t-a file. I'll hit enter now. 2, 3, I'm gonna hit Control C, and we should expect that it should now say 17, right? So I'm gonna use WC file, I'll hit enter, and yeah, it's 17. It was appended rather than being totally replacing the file.
What if you run it again without the append option?
Sure. So I will now I'm gonna just recall again because I'm lazy. I'll delete the dash A. I'll go 1, 2, 3, and then hit Control C, and then let's use WC again, and we can see now it's only 3. And if I cat the file, then we can see, yeah, it's only 3. It was fully replacing it. All right, any questions? Okay.
Got a question.
Sure.
on this. If you did not use the dash A, you use the pen sign itself after the T, would that do anything?
A pen sign, like the double.
The double thing.
You're saying, so how would it look? Where do you want me to put it?
Yeah, like right after the T.
Like this?
Yeah.
So this would be, it would read this as a file name, I believe. Let's just see what it does, because I could be wrong. Let's just see what it does.
It doesn't display.
Oh, okay. So I think what it's doing here is that it is passing it into T. T is then putting it into standard output, and then it's appending that output into file.
Oh, okay.
So this might actually work as well, and we can just use WC file.
I wonder if it's doubled up or no.
This is a good test. Okay, so let me just remove the file. So what this command is doing is it is running main.sh. Main.sh is writing to output. That output is being passed as the input to T. T is writing to output because it's what T does is it'll write to some file. If the file isn't provided, then it'll just write to output, and we can confirm that by looking at the man T. Yeah, the file is an optional parameter, but it'll copy the standard input to each file and also to standard output. So since there's no file specified here, it is just passing to standard output, and then that output is being appended to the file. So it's like a 3-step process. Any questions about that? It's kind of confusing. So I can yeah.
Yeah. So would it be the same as like if you didn't have like T there and you were just like?
That's a bit
It would be the
It's kind
same.
of like-
So what it's doing here is it's main.sh is writing to output. That output is being captured by T, and then T is just passing it again to output.
Yeah, it'd be like as if you like crossed out the file. Like,
Yes,
like,
yeah.
the file.
It's just going like that. So we're just making the pipe longer,
Isn't
basically.
it appending
So
twice
if
in
we're just
this
going
case?
here.
No, because T there's no argument telling write it into a file. It's just
Not about the argument because T does 2. One is the std out, which the arrows catches, and that appends it to the file.
So, yeah.
And it appends to the file anyway.
So
does
it's
that
not-
double do it or no?
Actually, it's not appending to the file anyways, because when we have this here, that is indicating to bash that this is the end of the t command. So t just runs like essentially this is the same as just doing running this by itself, and then you can see here it's just writing to output, right? We didn't pass in a file, so it's not writing to any file.
Oh, okay,
But then we're
got it.
taking that output and then appending it to the file.
Okay, got it.
Make sense?
It's the same as removing the pipe and removing T.
Exactly. So
Yeah.
this is functionally the same as just doing this. We're basically just adding more steps.
Okay, got it.
This was an interesting exercise. That's a good question.
Thank
Any
you. It's just confusing.
yeah. Any questions about that? Any does it seem confusing? But does it kind of make sense? I hope. Okay.
Exploding head git.
Yeah. Yeah. So okay, let's move on. Xargs is the next command we'll take a look at. The description I wrote for it might be a bit confusing, and I think again it'll make more sense as example, as do a lot of things in cybersecurity. Xargs will pass its standard input as arguments to the command you give, and it'll execute that command. Okay, let's just look at an example because I feel like this might be too confusing just in words. So I will cd back into lecture 2, and then I'll cd from here into the fourth example. Again, I just used tab completion there, so I typed 04 and then tab. And then let me type ls. And we can see here we have 2 files. So let's just look at the instructions first. Cat instructions. Okay, write a one-liner to delete only the text files. The text files don't exist in this directory yet, but init.sh will create them. So let me just run init.sh. In my terminal, if something is green, that means it's executable. So I'm just going to run it as a program, kind of like you run a.out in C. Let me just run that, and then let me type ls again, and we can see now we have these text files. So we want to write a one-liner to delete only the text files, and I'm going to challenge you to do this specifically using xargs. And so there's a few ways we can do this, but the idea is that we want to pass something into rm. So we want to write a command that lists the text files, and then have rm execute using that. So how this would work is we want to have some command that lists only the text file. So I'm just going to scaffold right now, so these aren't real commands, but I'm going to type list text files, and then I want to pipe this into xargs rm. What this means, so if list text files was a real command, it would output all the text files into standard output. It would just give us a.txt, b.txt, c.txt, d.txt, and it would end its stream. It'll output that into standard output, and then xargs will pick that up and pass it into rm. What that means is rm will see rm will run. So xargs will run rm a.txt, b.txt, c.txt, d.txt. Does that make sense?
As the arguments of a single command. Right?
Yeah.
They're now running the command 4 times.
Yeah. Any questions about that? So if we did just run that directly, and I will, since we have the init.sh, we can just always bring the files back, but I'll just run it one by one. So a.txt, b.txt, c.txt, d.txt, hit enter, and I'll type ls, and you can see now the text files are gone. But I'll run init.sh again. We want to find a way to do this using xargs. So from last lecture, does anyone remember a command that can be used to find files? I kind of gave it away.
Fine.
We could use the find command.
You could just use the find command, that's correct. So let's use the man pages for find in order to build a find command that only gives us the text files. So let's look at the man page. Okay, search for files in a directory hierarchy. So we need to pass in some expression, and we need to give a starting point. So I want to see if there's examples here, because I always like to use those. I'm just scrolling down to the very bottom. Let me just use, if I type Shift G, that'll also take me there. You can see here, that's not examples. Okay.
Again, how do you go up and down?
Sorry?
Up and down arrows, page up, page down.
Yeah,
I
there's-
don't know what the Vim commands are for like.
Yeah, currently I'm just using my trackpad actually. I'm just scrolling. That'll also work. It's kind of cheating, but it'll work. Okay. So find will allow you to just type in an expression and give you the files that are currently there. The way I often like to do it is there's this command called, there's this flag called -name. Let's see. So -name will allow you to pass in some pattern for a file. For example, if you want to look for any text file, you might use this in your normal file explorer, like your graphical user interface file explorer. You can type star.txt, right? And that'll give you any file that has .txt at the very end of its name, right?
Yeah.
Sound familiar?
Wildcard.
Wildcard, yeah. So this is something that I like to use with the find commands a lot. The way that it works is you just have to type find. You have to give it a starting directory. So I can type /. Dot refers to the current directory. And / is just specifying that it's a directory. It's kind of redundant. I can type -name. And then I can pass in star.txt. I'll type this and I'll hit enter. And you can see now it gives us these 4 files that we're looking for, right? Any questions about that command?
Now you plug that into the args thing.
Yeah, Michael? Do you need to put quotes? I don't believe so. Sometimes I do it just for, oh, you do, okay. It's just based on how it's parsed, I guess. It depends on the command.
I think you technically don't need the slash as well. You could just use
Yeah, you don't need the slash. So this would just work fine, I believe. Yeah, okay. And right, so like you were saying, now we have that magical, list text files command, and then we can pass it into xargs. So I will now type pipe xargs rm. And this will just run rm, and it'll say rm./a.txt space ./b.txt, and so on. And I'll hit enter. We can type ls. We can see that they're gone. We can rerun this command here just to list all the text files, and we see nothing. So there's no longer any text files. So we completed that task. All right. Any questions about that? Yeah.
So if you do it without the XR, it just does like the first one, or?
If you do it without the xargs, I believe this will still work actually. The reason for using xargs is because sometimes, actually, it will not work. So when you do it like this, what this means is we're taking this output. So remember, find.name.txt. It gave this as an output, right? Pipe will then take that as an input. So it'll pass that as the input to rm. So it's more like we're typing in rm and then passing in .a.txt, b.txt, c.txt, d.txt as like input. But it doesn't expect that. Like rm is not a command that expects input. So we can try it. I don't believe it'll work, but we have these commands right now.
There is a difference between arguments you're passing to a command
Yes.
and like it reading input, right?
Yeah.
I mean, from a C perspective, you've probably seen like the, oh man, what was it? std args, std.
Oh yeah, arg h, argc.
Yeah, argc, argh versus.
Argv, sorry, argv.
Oh yeah, argc, argv versus just like, I don't know, std in. I'm like mixing up my.
Doesn't the arg thing handle where it should be for the rm or like whatever rf the command you're using? Because if you're doing just rm, you're not going to get arguments after it, so it doesn't.
Yeah, so when you do rm, rm can take arguments, right? So if I type man,
You give it after, you give it before.
The
You can do
question is, can you add arguments to xargs? Can you add like flags and more stuff to xargs so
I mean,
it doesn't just run rm?
If he pipes it, then the outputs of the first one will be handled to the RM. But do they get before the RM or after the RM in this
So-
case? Because they should be after in the actual use of the RM itself.
are you asking about like in this case where I have?
Yes.
Yeah. So in this case, what it's doing is it's taking in the find command here, and it will pass. So find will give us an output, right? We saw that over here. Let me just run it by itself. Find will put an output into the terminal. It'll put an output
Yes.
into standard out, and it'll take that output and pass it as the input, the standard input to RM. So if I typed it in as like this, then it's taking that output and passing it as input to RM. The reason why this won't work is that RM doesn't read from input. So reading from input is what you would do when you run scanf in a C program. Scanf will wait for user input, right? It'll wait for the user to type in some useful strings that the program can then use. Like for example, in that first example that we had here, like the O1 stdio, if I run .a.out, this is using the standard input. So it's expecting me to type some words, and it'll write that to output. The difference is that RM isn't looking for any type of standard input. It's looking for arguments that you pass in. So if I wanted to type remove a.txt, this isn't standard input. This is just a command argument. Does the difference there, is the difference there confusing to anyone? It is. It's okay if it is.
Time check. We have about 20 minutes.
Okay, that's all right. So, okay, in that case, I'm assuming that we're all right. So, the difference is that with xarg, you're taking in input and passing it as arguments to rm. So if I wanted to pass in an argument to rm, for example, just type in rm a.txt. A.txt is now an argument. I can type enter, and that works fine. And the reason why piping directly to rm didn't work is that it passes it in as the input to rm, and rm is a program that doesn't take input. It's not doing a scanf at any point. Any questions? Yeah.
Like if this was like a home loop, then should we care about new lines and file names?
New lines in file names?
Yeah.
No. We can assume the file names won't have any new lines. Yeah. Okay, I'll move on then. There's just a few other commands that we'll talk about, and then we'll go into regex. So, okay, grepping for stuff. So we learned about, I think we might have used this a little bit last lecture, unless I'm mistaken. Grep allows you to search for lines in standard input which contain some pattern. What does that mean? Let's look at an example. So let me cd out, type ls again, and then cd into the grep exercise. I'm going to type ls just to see what's in here, and let's cat the instructions. I'm going to type tab to autocomplete. Okay. This program will look through the scan file and understand how it is formatted. It's asking us. So look through the scan file and understand how it is formatted, then write a grep command to search for all lines which contain IP addresses. Let me type cat scan.txt. And you can see, wow, okay, that's really large. Let me instead use less to view it, to page it. And we can now use the arrow keys. So we can scroll through and see how it's formatted. There's a lot of text here. Fun fact, I pulled this scan from one of our competitions that we participated in with the club. And you can see that there's IP addresses here. An IP address is just a number that's used to refer to any computer on the internet. And you can see that there's a lot of these. So we want to write a command that instead of, so similar to how cat gave us that long output that we had to like scroll to read, we want to just take out these IP addresses. And so how can we do that? Grep is a command where you can cat a file, pass it into grep, give it a pattern, and it'll only return lines that match that pattern. So if I wanted to cat the file by itself, it gives us a lot of lines, right? But if we just look at the format, so knowing that we only want the IP addresses, let's look for something that exists in all of the lines that have IP addresses. We can see a kind of a commonality. They all contain this line that says nmap scan report 4. And so grep accepts a pattern of any sort and that you can pass into it, and we could pass in this as our pattern that we're looking for. So I hit Control-Shift-C to copy that to my clipboard. I think you can use Command-C if you're on a Mac. I'm going to type pipe. I'm going to type grep, and then I'll put quotes and put that string into the quotes. And now I'll grep for that. So what we expect is that it'll return only the lines that contain IP addresses, because only the lines that contain IP addresses have this string that says nmap scan report 4. And we'll hit enter now, and you can see, yeah, it returns those lines. Any questions?
Note that it returns the whole line, not just the maybe specific IP address we're looking for.
And that's an example we'll look at in a little bit. Hey, I'm not on the internet anymore. Okay, cool. Okay. And there was a little note that I wrote here that says grep-v will do an inverse match. So if I wanted to do the opposite, so I wanted to look for any line that doesn't contain an IP address, just type -v and hit enter. And wow, there's no longer any IP addresses. There's no longer any IP addresses, and we just got rid of them entirely. Any questions about grep? One last note is that grep does support regex. We'll talk more about what that means later if we have time today. Otherwise, it'll be Tuesday's content. Okay, sed. So sed is a command that will perform transformations on an input. What that means is it'll take its input and it'll allow you to do like text substitution and things like that. So if you type sed s, I believe it stands for substitute, and then type some original string, and then you want to type its replacement, then it'll go through the file that you're looking at and replace all of the instances of that original line with the replacement.
Or not just a file, but whatever you feed into standard input.
Yeah, whatever you feed in. So let's look at the example for that. Let me cd back, cd into 06, type tab, and let's type ls, see what's in here. Okay, we have greetings.txt and instructions. Let me cat the instructions. Greetings.txt has some errors in it. Use sed to 1, fix the errors, and 2, put the output into fix.txt. Okay, let's look at greetings. Hello, what is your name? Where are you from? How are you doing? Which operating system do you use? What's the error here? This is like a pointless exercise. But what are we trying to replace? Go ahead. Z with H, right? So anytime there's a Z here, we want to replace that with H. So let's use sed to do that, right? So we can pipe in that output into sed, type s/ the original character we're trying to replace. So what are we trying to replace?
The Z.
The Z. So we type in Z there, and what are we trying to replace it with?
Edge.
With H. So let me do that. So cat sed. This might help if I show the format while we're typing. Let me move this up if I can. I'll have to shrink my terminal.
If you're doing one character, you still need to quote it. Or like
So the reason we quote it is just because we're quoting the entire string. So I think that's just how it sed expects. I believe that if you don't put the quotes, it'll fail, but definitely feel free to try that. I can try it right after I do this, but yeah. So we're replacing Z with H, and I'll hit enter. And now we see it's mostly right, except we see this one line here at the bottom that is still not right. So this is a line where it had two Z's. So we had a Z here and a Z here. And we can see that the first one was replaced, but the second one wasn't. The reason for that is that sed tries to operate at a very, it doesn't want to do more than you ask it to do. So if you wanted to correct all of the instances, if you want to replace every Z within one line with an H, so replace each Z in a line with H, it doesn't do that by default. By default, it'll look line by line. It'll only replace the first instance. So in order to correct that, we add this flag here. You just type G, and that'll mean global. So it'll look through every single instance of the line. It'll look through the entire line, see where there's a Z, and replace all of those Z's with H's. So now when we hit enter, we should expect that every Z in this line, the one that was here and the one that was here, will get replaced with an H. Let me hit enter, and you can see that worked successfully.
This is glorp erasure.
It is glorp erasure. All right, let's move on. Just a quick note. So today we used pipes a lot to read files, but many of the commands that we talked about today actually just support taking files in as arguments. So for example, if you want to find a word count for a file, this is the way that we did it during last lecture. We just typed WC file, and I think we also did that today. You can just pass in the file as an argument, and it'll read that file. The same thing exists for sed. So for example, if I wanted to actually replace the text in the file, so actually there was, this is kind of incomplete because there was one other, I'm going back for a moment and then I'll come back. The other part of this was that we wanted to put the output into fix.txt. There's two ways to do this. Does anyone remember how we can take an output and put it into a file? Append it, how?
You want to overwrite it, or you just
Either way, but how would you do? If you wanted,
2 arrows and then
Sure.
file?
so you could either do 1 or 2. Since we don't have a file yet, I'll just do 1, but you could do 2. I'll just type file,
Or T,
it was fix.txt, or T, right? So you could either do it this way, or you could pipe it into T. And it gives us an output as well. I'll do cat fix.txt, and we can see it's there now. All right, cool. So yeah, so this was sort of a manual way to write to a file. If you wanted to write it directly to a file, then sed accepts just a file as an argument. So it'll read the file directly if you just type in file. So for example, if I want to just, instead of doing this cat greetings.txt, I can replace this all with just passing in greetings.txt as an argument. So now it's an argument. It's not reading from standard input. It's just reading its arguments. So you can see that worked. This is more stuff that you can find out if you read the man pages, but it didn't actually do the substitution to the file. Like if I typed cat greetings.txt, you can see it's still incorrect. The only way to get it to actually overwrite itself is by typing -i dash I means in place, so it'll do the substitution in place. It'll do the substitution on the file. So I'll type sed dash I. I'll type cat greetings, and now it's actually been updated. Any questions about that? No? All right. Cool. And again, if any questions come up later on, feel free to just send a message in Discord. I think there's a role, it's like ECS198F instructors. You can just ping us and we'll get on there. But also all of us have notifications on for the server, so we hopefully won't take too long to respond. So there are certain instances where you will definitely want to use pipes, and we'll have an example to talk about why there are certain cases where you definitely want to use pipes rather than doing something else, rather than using this file, using file as like an argument, for example. Okay, chaining commands. So this is really why we would want to use pipes a lot. So if you wanted to find all lines in a file which contain hi, you could just cat the file and then grep hi. Or you could type file at the very end of the grep command, and that'll work too. The reason we might want to use pipes is that sometimes we want to add more operations to a command. So for example, find the number of lines which contain hi. Then you would grep the file and then type pipe and run wc-l. wc is word count, -l means just give me the line count. And this is just a way for you to say, take the input of the grep command and then pass it into word count to give us the line numbers. So chaining commands is just a way for us to keep adding more operations to a command. And so the challenge with assignment 1 is that every command that you make should be a chained command. Well, there's some. I should clarify. There are some parts of the assignment where you can probably just do it with one command. But a lot of times you'll have more complex operations, and so you will want to use piping in order to add more steps to the command. So this is all one command by itself, but they're all piped into one another. And I believe we have an example. Yeah, exercise 7. So let me just cd back out and cd into 07. Chaining. Let me type ls. We can see there's hint1, hint2 instructions, and scan.txt. Let me cat the instructions. See the scan file. Find a way to return only the IP addresses. OK, let me. This is the same scan file that we had before, so it should look kind of familiar. We can do less, again, to just view it in a paged format. But it's the same file that we saw earlier. So remember, what we did before was we just grepped this file, right? So I just, we did cat scan.txt, and then did grep for this line. So let me just do that again. And we can see, OK, again, it gives us the entire line output, right? It's not just giving us the IP addresses, it's giving us the entire line. But let's say we wanted to, we had a command called like hack, and then we wanted to just pass into hack all of these IP addresses. If we took in this output and piped it into hack, then it will end up having all of this garbage that it doesn't want to see, right? Like all it wants to do is know what the IP addresses of computers are. It wants to know 10.100.100.1 is a computer that we need to hack. But now we're passing in nmap, so it ends up running nmap. We end up passing in nmap into hack, which doesn't. It's just useless noise that it shouldn't have. So we want to find a way to remove all of these strings. So let's take a look at the hints. So the first hint is. Wait, are there any questions about what the exercise is trying to do? So we just want to get the IP addresses from that file. We want to remove anything else. So let's look at hint 1. Find all lines which contain IP addresses and remove all text except for the IP address itself.
Anyone have any ideas of what command might be relevant?
There was someone said something. Said? Yeah. So there was another hint here that might give a better idea of why. So you can remove a string by replacing it with an empty string. So what is the command that replaces text and like with some original text and some replacement text? Sed. Sed was the command that we did just a couple slides ago. It'll take in standard input. It'll read from standard input. It'll allow you to replace some text with some other text, right? So we have this line here, and we want to remove any instance of nmap scan report 4. So we can use sed to do that, right? Maybe just for a moment, like maybe just try it out by yourselves or work with the person next to you. to just try to write a sed command that will remove this nmap scan report 4. And we can reconvene in like a minute or so.
Doing that after the graph wouldn't affect the graph results, because if it's gone, the graph is already doubled, it's like fetching the lines we need.
Yeah.
So yeah, grep runs executing, and then you move it to sed.
Yeah, I mean, it just stores like the output in a buffer. It doesn't really touch the original scan.txt text unless if you specify it to.
So as long as we're not using the dash I thing, it's not gonna.
Yeah.
So the reason why we wouldn't even use dash I is because dash I is in place, which implies that you're giving a file, right? Right now, it just has an input, a standard input to sed.
So it doesn't know
So
what.
it's not gonna change the original file.
It doesn't show anything.
Okay.
You gotta make
Actually, it
it
doesn't even
like-
see the file. Because sed executes in such a way that all it sees is the input, and so there's no file that is associated with just text.
Right output of graph. Okay, got it.
Yeah, good
You
question.
have this.
It's been 1 minute. Let's
You want-
reconvene.
you want-
Any questions so far?
New addresses.
I'll show the solution, but yeah, all right, let me just show it. So the way that we would do this is, again, sed is a command that takes two parameters. So you type in the string that you want to replace and then what you want to replace it with. We wanted to replace nmap scan report 4. And then I'm also just going to remove the space because then it'll, actually, let me just first do it without the space. So I'm just going to paste, I'm going to copy this, so Control-Shift-C. I'll do Control-Shift-V to paste. And then we want to replace it with nothing, so we just put nothing here. And then I will hit enter. And you can see now we just have the IP addresses. There was something a little bit annoying, which is that there's this space here. The reason that space is there is because the string that we typed in to substitute was nmap scan report 4, and you can see that there's a space and then the IP address. So if I just hit the up arrow and then add a space and hit enter, now it's just, you can see that it's been removed. So now we can safely type in hack and it'll hack all those computers if that command was real. Any questions? Go ahead. Or was that a question? Yeah.
Is there a way to do it where, like, say you don't know what the text is exactly, but you want to skip all the text and reach the character of the root?
Yeah, so that's something we won't have time to talk about today, but there's these things called regular expressions, and you could write a regular expression that will look for an IP address, and then you could write a more complicated sed command that will look for, it'll match all the text in the line that isn't an IP address, and it'll remove that text. So you're basically just modifying this part here. So because you don't know it says nmap scan report 4, right? So you would look for any text that is preceding an IP address, and it'll remove that. So it's a more complicated operation. The nice part about this example is that it's very consistent. But yeah, good question. Did that answer that?
Yeah.
Yeah. And you had a question?
Is there something besides the star that is kind of like the wildcard but replaces only one character in this case? Because you know the structure of the IBM
Mhm.
just pass in 2 and 3 and whatever of that.
Yeah, of like the numbers? Or
Yeah, then you're just passing the dots, you're just matching format at this point.
yes, that would work. That's regular expressions. We'll probably talk more about that on Tuesday's lecture. Unless it's right here, I kind of forgot. It's right here. Well, let's take a few minutes to talk more about regex, and then we'll
We'll just describe
reconvene.
what it is before
Yeah.
diving in.
So I think a lot of the questions we've gotten have already been along that pattern, but a regular expression, or shortened to regex, whatever you want to call it, is a sequence of characters that is used to precisely match text. So this is a pretty simple regular expression. You're just typing in hello. It'll match the word hello. So if we had a file that had hello in it, then we could use hello to match hello, if that makes sense. So let me, I think there was an example here. So like, but not for that. So let me just make a file called like file, type hello, by, and let me cat the file. I want to just match lines that have hello. Then I can just type hello, grep hello, and it'll match all the lines that have hello. And only this line, only line 1 has hello. So hello is a very simple regular expression. You can also type by, and that's also a very simple regular expression. The letter H is a very simple regular expression. Basically, any type of text is a regular expression in and of itself, and it's being passed as an argument to grep, which is using that in order to just look for text that matches that pattern. A more complicated regular expression would be H and then this block here, LLO. I'll talk about what that means in the next slide, but this regular expression will match H0 LLO, H1 LLO, H2 LLO, all the way up to H9 LLO, whatever that means in any specific file you're looking at.
I mean, anyone want to shout it? Oh, wow. There.
We're talking about it now. Yeah. So sets are a pretty useful operation in regular expressions. It means you're matching any character within the set. So when you had this expression here, what we were saying is 0 to 9 is a set. It's a set of the decimal numbers, right? The base 10 numbers. And we want to match any number in that set. So we want to match H, then any number in that set, then the letters LLO. So let me just change this file. So I had that file called file. Let me change it to H0 LLO. And then if I ran that command again, so this was a grep command that just looks for the letter H. So the regular expression is just H. I hit enter, and it just ends right there. If I typed hello, so it matched a line because the letter H was found. It matched successfully. If I type hello and hit enter, nothing matches because now that regular expression doesn't exist in the text. But if I wanted to replace it with H0 LLO, that'll work. If I wanted to replace it with a set, for example, 0 to 9, this will also match. And if I change the text to H9 LLO, so I wrap around, I save the file, then if I cat the file and look for this set again, it succeeds. So a regular expression is just a way for us to write a more complicated string that matches some text that we're looking for. There's many different types of sets, so I realize we're right at time. Let's just end there. We can talk more about it next lecture.
Talk more about next week.
If there's any questions, we'll stick around for a bit.
Thank you for coming.